Welcome back to Geometry, Measurement, and Probability. In this video, we pick up in section 11.4 with regular polyhedra. So let's get started. First, we have what's called a convex polyhedron. Earlier in chapter 11, we talked about convex versus concave. Concave caves in and convex does not. The same thing is true for our polyhedron. A convex polyhedron does not cave in anywhere. Now, a regular polyhedron is a convex polyhedron. The sides are regular polygons, and every side is congruent. And what happens in a regular polyhedron is the number of edges that meet at each vertex is the same for all of the vertices of the polyhedron. The regular polyhedra, along with their interiors, are known as our platonic solids. There are 5 regular polyhedra. On the top left, we have our tetrahedron. It has 4 faces, and each of these faces are equilateral triangles. In the middle, on the top row, we have a cube, which has 6 faces. All of these faces are squares. And on the top right, we have an octahedron, which has 8 faces. All 8 of these faces are equilateral triangles. On the bottom left, we have a dodecahedron. A dodecahedron has 12 faces that are all pentagons. And on the bottom right, we have an icosahedron. An icosahedron has 20 faces, which are all equilateral triangles. On your screen and in your notes, you'll see some more information about our regular polyhedra. We use what are called nets to construct our polyhedra. The nets below are used to construct the 5 regular polyhedra. What would happen is you would fold these nets along the dotted lines. So on the left, we have the net for a cube. Notice there are 6 squares there to make up our cube. The next net is for the tetrahedron. There are 4 equilateral triangles. We have the net for the octahedron next, then the dodecahedron, and last, the icosahedron. Euler was a mathematician who studied the relationship between the number of faces, edges, and vertices of polyhedra, and he came up with a formula, V plus F minus E equals 2. Here's how that formula is used. Look at example 2. An octahedron has 8 faces and 6 vertices, and we want to know how many edges the octahedron has. So we use Euler's formula. V plus F minus E equals 2. And I plug in the information that I know. There are 6 vertices, there are 8 faces, and I'm looking for the number of edges. 6 plus 8 is 14, and bring down the rest of the equation. To solve for E, we subtract 14 from both sides, divide both sides by -1, and that tells us that our octahedron has 12 edges. Look at our next example. A house has 9 faces and 17 edges. How many vertices does it have? Again, we use Euler's formula. V plus F minus E equals 2. We are looking for V this time. There are 9 faces and 17 edges. 9 minus 17 is -8. Add the 8 to both sides to solve for V, and we get that there are 10 vertices. Another type of shape that we have in 3-dimensional geometry is a cylinder. A cylinder is a simple closed surface. It's not made of polygons, and our bases are going to be in parallel planes. The first cylinder that you see is a right circular cylinder. It is right because it's straight up and down, and the bases are circles. The next cylinder is an oblique circular cylinder. It is oblique because it leans to one side or the other, and again, our bases are circles. The last cylinder we just call an oblique cylinder. We don't have a name for that base, so we just call this an oblique cylinder. We also have cones. Cones are to cylinders like our pyramids are to prisms. So we have a base, and then our base comes up in a point. Our first cone is a right circular cone. It's right because it's straight up and down, and the base is a circle. The next cone is an oblique cone. It's oblique because it leans to one side or the other, and we don't have a special name for that base. And then the last cone is an oblique circular cone. It's oblique because it leans to one side or the other, and the base is a circle.